Hi all, today we're going to go through topic 6, quantitative analysis. So our learning goals for today are to learn about conducting solution stoichiometry. And we're going to see this really isn't anything new. This is identical to the stoichiometry that we've been doing before. So for today, we're really just going to work through one sample problem to get a little bit comfortable doing it. And then we'll have a worksheet where we'll be given different scenarios to practice conducting solution stoichiometry. So solution stoichiometry is a method of calculating the concentration of substances in a chemical reaction by measuring the volumes of solutions that react completely. Often it's called volumetric stoichiometry. But like we said, it's the same as the stoichiometry that we did before, but we're dealing with solutions. Okay, so we're not going to necessarily be given masses and of substances, we're going to be given concentrations and volumes. Okay, as we work our way through, we'll find that we're going to have the two mixed, but it really doesn't change anything in our approach. So when we're performing all stoichiometry problems like we did before, right, we always start off with a balanced equation, right, and we need that to get our mole ratios. Okay, we're always going to convert whatever value we're given into moles using whatever conversion factor we're going to need. From there, we're going to work our way across our balanced equation using mole ratios to solve for the amount of moles of whatever we're asked for. From there, we're going to convert to whatever factor they want us to get. Before, maybe we did mass, but now we might be asked to solve for a concentration or volume. Okay, so let's look at this sample problem and see if we can work our way through. So it says, what volume of 14.8 moles per liter NH3 would be needed to react completely with each kiloliter of 12.9 mole per liter H3PO4 to produce fertilizer in a commercial operation? So as always, we need to write out a balanced equation. Okay, so in this case, we have NH3 reacting with H3PO4, and this generates NH42HPO4. Okay, you would be given this product. I know it's not explicitly told in the question, but you're not going to be expected to predict products for reactions that we have not looked at. Okay, so from here, we're going to try to organize our information and set up a table. Okay, so we can go through similar to before where we did N mass molar mass. We're going to do N, C, and V. Okay, whether you put it under the arrow over here or on the side here, that's perfectly fine. I'd probably still just put it on the side here as we're going through. Okay, so if we look at the information that we're told, it says what volume of 14.8 mole per liter NH3. Okay, so if we're looking under NH3, we can put a question mark here for volume. We're told our concentration is 14.8 moles per liter, and it says would be needed to react completely with each kiloliter of 12.9 mole per liter H3PO4. So this is our concentration, so we put 12.9 mole per liter under H3PO4, and we're told that we have 1.00 kiloliters, and we need to convert that to liters by multiplying by 1,000. Okay, so we have 1,000 liters here. Okay, now if we look at this, we're trying to solve for the volume over here. Okay, and if we think back to our workflow from before, it's no different. Okay, so we're trying to work our way up, okay, to solve for our moles. Okay, once we know our moles, then we're going to try to work our way over using our mole ratios. Okay, and then once we have this, we can work our way down using one of our mole equations. Okay, so in here, we're trying to solve for moles. So our equation involving moles and concentration and volume is N is equal to C times V. So we're going to multiply these two numbers together, and we get 12,900 moles. Okay, so from there, we can write that in here. So we know that we have 12,900 moles of H3PO4. So now we're trying to solve for the moles of NH3. Okay, and we're going to use our mole ratios. So we have a mole ratio of 2NH3 to 1 mole H3PO4. So we can solve for the moles of NH3. So that's going to be 12,900 moles of H3PO4 times 2 moles NH3 over 1 mole H3PO4. Okay, and we're going to end up with 25,800 moles of NH3. Okay, now we're going to work our way down. So we have N, we have C. So we know that N is equal to C times V, so V is equal to N divided by C. Okay, so we're taking our 25,800 moles and dividing it by 14.8 moles per liter. Our volume is then going to be 1,743 liters, and based on sig figs, I'm going to round that to 1.74 times 10 to the 3 liters. Okay, so our required volume of ammonia would be 1.73 times 10 to the 3 liters. Okay, so that takes us through sample problem 1. If you look in your notes, I do have full solutions for the rest of the problems. Please read through them, okay, and we will be going through this in detail during class.